Welcome to 8.2.5, Rules with Scientific Notations. We have all of the learning targets that we've accumulated so far in our independent Unit 8 lesson. We are on the very last one. I can apply the exponent rules to scientific notation. Make sure you've downloaded your to-do list. So today we're going to work with scientific notation again, and make sure you remember the rules. The decimal goes after the very first non-zero number. You eliminate all the essential zeros. You use the multiplication symbol, not a dot, and your exponent base is always 10. Here are the rules going from a big number, 6500000. Your decimal would live here. You want to move that decimal. We are moving it 1, 2, 3, 4, and 5 spaces. It's positive 5. You rewrite it, and you put your exponent up there. For the negative numbers, you are going, or the small numbers, you're going 1, 2, 3, but that is a negative 3. So you write the decimal here, and your power is negative 3. So let's practice these together. Your decimal is living here, 1, 2, 3, 4, and 5. It's a plus 5. We have 5.401 times 10 to the power of 5. This is a teeny number, so you're going to have a negative exponent. 1, 2, 3, 4, and 5, negative 5. 8.7 times 10 to the negative 5. This is not correct because the decimal needs to be right here after the first non-zero number. That's a negative 1. So we're negative 1. So 9.5 times 10 to the negative 5. So the product rule will apply when we are multiplying two numbers with the same base. So these are rules, numbers written in scientific notation, and here is your base. Your base is right here, the tens. Okay? So you are going to keep the base and add your exponents, but you are also multiplying the constant values. So when you multiply 5.6 times 2.1, the answer you get is 11.76. You bring your multiplication down, times 10. You add your exponents to the power of 7. But you're not done because you have to move your decimal one place. So we're going to add 1, and we rewrite it as 1.176 times 10 to the power of 8. This is an example of the power rule. You have your exponent, and it is being applied here. Your base is 10. It is also being applied here, and this is a constant multiplication. So when you do this, you end up with 3.9 cubed times 10 to the power of 6. Then you have to expand 3.9 cubed. When you do that, you get 59.319 times 10 to the power of 6. But you have to move your decimal, plus 1. So you get 5.9319 times 10 to the power of 7. We can also apply the quotient rule when we are dealing with scientific notation. I want you to remember that you have two things happening here. You have a division here, and then you have the application of the quotient rule, which would apply right there. So you're going to have 4 over 8, and then you're going to have 10 to the power of 5 minus 3. So 4 over 8 is 0.5. It's a half times 10 to the power of 2, but you have to move your decimal place, minus 1. You get 5 times 10 to the power of 1. Okay, so I want you to practice these. Tell me what the rule is, and then figure out how you do it. Come back and check your work and see if you're right. So there's your answer. How did you do? It is the product rule. You are multiplying 3 times 2 to get 6, and you are adding the bases. 2 plus 3 is 5. Again, give it a try, see how you do, come back and check. Pause the video if you don't want to get to the check first. Okay, how did you do? It's the product rule again. You're multiplying 2.75 times 2.5. You get 6.875, and then you are taking negative 2 plus 8 to get you 6. This is our last example, and this is our quotient rule. It's division. I'm going to rewrite it for you in case you're not exactly sure how to write it. So it's 2.75 times 10 to the power of negative 3 divided by 5.5 times 10 to the power of 4. Give it a try. Come on back. Pause first. Okay, so this is an example of the quotient rule. Like I said, when you divide 2.75 by 5.5, you end up getting as a solution 0.5. And then you take your exponents, negative 3 minus 4. The result of that is right here, 0.5 times 10 to the negative 7th. But you have to move your decimal, that's what I did right here, over past the 5, so you're subtracting 1 more. Your answer is 5 times 10 to the negative 8. You are going to be very tempted to remove this, but you have to remember that this is scientific notation, and negative exponents are okay in scientific notation because they mean that the number is between 0 and 1.